Hello YouTube. I've received a lot of questions lately regarding what to look for when purchasing a power supply. So in this video I'm going to briefly go over some of the technologies, certifications, and how to calculate the base wattage that your system will use. Starting off with some of the technologies and certifications, the power supply you purchase should include active PFC with a rated value of as close to 1.0 or 100% as possible. In terms of energy efficiency, I recommend it be 80 plus certified, which means that it's certified at 20%, 50%, and 100% load to be above 80% efficient. Most mid to high-end power supplies will be between 85 and 95% efficient. Your power supply should include overcurrent, overvoltage, undervoltage, and short circuit protection. It should use Japanese capacitors that are rated at high temperatures. It should follow the ATX standard, and it should be the most current standard, which is version 2.2. On a side note, it could also follow the EPS standard as long as it also includes the ATX standard, though the EPS standard isn't really required and it's more oriented around servers. It should be able to receive an input voltage of 115 volts to 230 volts for American and European standards. Most power supplies will include a red switch on the back to change between these two voltage settings, though if you prefer, some do sell with auto switching capabilities. A lot of high-end ones come standard now with that. The power supply should be sufficiently cooled, and of course silence is a preference. Usually the larger the fan in the power supply unit, the quieter the unit will be. I recommend most units with 120 millimeter fan or 140 millimeter fan, though there are some very high quality 80 millimeter fan units out there. Also, the unit should be thermally controlled, so as the temperature of the power supply increases, so should the RPMs of the fan. You should keep in mind the dimensions of the power supply. Most ATX power supplies are roughly 90 millimeters tall by 150 millimeters wide, and will go usually between 150 and 200 millimeters deep, depending on, again, the power supply. Usually the higher rated power supplies with more wattage are larger. So keep in mind the dimensions so the power supply will fit in your system. Also keep in mind the connectors you will be using. You're going to want a 24-pin motherboard connector, either a 4 or 8-pin CPU connector. Most quad cores require an 8-pin CPU connector. You're going to want as many Molecs as you require, which are usually for some hard drives or optical drives. As many SATAs as you require, and the PCI Express is dependent on what graphics solution you have. A lot of single card solutions require 1 to 2 6-pin connectors, or some of the higher end solutions and multiple video card connectors may require some 8-pin or, of course, multiple PCI Express connectors. So keep in mind your specific needs. Also, if you're using multiple video cards, it's best but not necessary for it to be certified by the vendor or by the technology you prefer to use. If you're using SLI, it's best for it to be or meet the SLI certification, and the same goes for Crossfire. You're going to want a high mean time between failure rating, roughly, I'd say as a minimum usually 100,000 hours is best. You're going to want your manufacturer to provide a high quality long-term warranty, usually of 3 to 5 years. And you're also going to consider cable length. If you have a larger case especially, or if you're routing cables behind motherboards, you may need to purchase separate cable extenders separately, or just purchase a power supply that comes with longer cables so that they can reach their proper devices. Also, some preferential things, you may want modularized cables so that they can be removed, and this helps eliminate some of the cable mess inside the case and improves airflow. You may want to keep in mind the aesthetic appeal, the color of the power supply, how it's painted, maybe if it has specific lights or, I don't know, a mirror coating or something of that nature. Also, if it's sleeved or not, which helps with the aesthetic appeal as well as some cable management and airflow. There are other noise reducing methods as well, such as silicone pads or rubberized edging on the power supply that can be an added bonus. Now I'll briefly go over how to calculate the wattage.
Now we'll go over a simple means to estimate the peak power consumption of your system. If you have a dual-core CPU, expect your processor to draw no more than 95 watts. If you have a quad-core CPU, expect your processor to draw no more than 130 watts. Also, if you plan on OCing your processor at all, take this into account. Usually increasing your estimated peak CPU power draw by about 50% should more than account for any OC. In order to determine how much power your graphics card will use, consider the following. If your graphics card has no additional power plug on it, it will not use more than 75 watts. If it has a single 6-pin power plug, it will not use more than 150 watts. If it has two 6-pin power plugs, it will use less than 225 watts. And if it has a 6-pin and an 8-pin power plug, then it will use less than 300 watts of power. Keep in mind that most cards will consume a lot less power than is able to reach the card. If you plan on using a multiple GPU setup, then simply add this number for each graphics card you intend to use in your system. For every 7200 RPM hard drive, add about 10 watts to total system power consumption. For every 10,000 RPM hard drive, add around 15 watts per drive. For every optical disk drive you use, add about 15 watts per drive. And for every fan, add about 3 watts per fan. Lastly, take into account the following. Your system motherboard and memory will usually use less than 50 watts of power. Also, add about 20% to your final total. This will help account for output depreciation of your power supply over time, differing operation environments, additional expansion cards, USB and FireWire powered devices, as well as possible system upgrades in the future. Don't get hung up entirely on how many watts you will need, as the estimates we went over are just that, they're estimates. For the most part, they are over-exaggerated quantities to help prevent you from purchasing a PSU that is underpowered for your needs. Also, there are other things to consider that I won't be discussing here, such as rails. For the most part, you shouldn't have to worry about the differences between a single and multiple rail power supplies, as long as you heed the following. You're almost guaranteed to have a power supply that will work great for your system so long as you purchase a high-grade power supply made by a reputable manufacturer that has all the leads that you will require. Also, use caution when using adapters, such as Molex to PCIe for a graphics card, as you may overstress one of the rails in your power supply or potentially cause other issues if you're not careful. The following are some reputable manufacturers, though they're not in any particular order. Keep in mind that these are basic guidelines to follow for determining what power supply you will need for your system, so always do your research before buying. As always, let me know if you have absolutely any questions or comments, and thank you for watching.